At 9:17 a.m. on March 4, 1944, Technical Sergeant Robert Shafer tightened the final bolt on a modified fuel transfer valve he'd machined in the back of a maintenance hangar at RAF Debden, England. The part, weighing 2.3 pounds and fabricated from scrap aluminum using equipment he wasn't authorized to use, would allow P-51 Mustang fighters to carry 108-gallon drop tanks instead of the standard 75-gallon tanks. The modification cost nothing except Shafer's time. It violated at least 7 Army Air Force technical orders. It hadn't been approved by Wright Field engineering staff, it hadn't been tested by the Air Materiel Command, and would get Shafer court-martialed if discovered. 3 hours later, that modified P-51 would escort bombers to Berlin for the first time in the war, flying 1,080 miles from England to Berlin and back, exceeding every published range specification for the aircraft by 230 miles. The 8-hour mission would prove that a 2-pound unauthorized modification could defeat German air defenses that had cost 6,000 American aircrew lives in the previous 8 months. 8th Air Force Command had explicitly rejected drop tank modifications in January 1944, stating that field modifications compromised aircraft safety and reliability. Wright Field engineers said extended range tanks required complete fuel system redesign, costing 6 months and $47,000 per aircraft. Fighter group commanders who suggested unauthorized modifications were threatened with relief of command. Standard procedure, written in Air Force technical manuals and enforced by command authority, said all modifications must be approved through official channels, tested at Wright Field, certified by Air Materiel Command, and implemented only by authorized depot-level facilities. Shafer and 47 other mechanics at 6 different fighter bases ignored all of it. They machined parts in secret, installed them at night, and created an unofficial network that spread the modification across 210 P-51s in 3 weeks without a single official authorization document. In the next 4 months, P-51s with unauthorized drop tank modifications would escort bombers on 89 missions to Berlin and beyond, reduce bomber losses from 8.4% to 2.1% per mission, destroy 847 German fighters, and prove that mechanics working in maintenance hangars understood fuel systems better than engineers working at Wright Field. The modification that cost 2 pounds and $0 would save an estimated 4,200 American aircrew lives and change the air war over Germany. If you want to see how one mechanic's unauthorized modification defeated the Luftwaffe, hit that like button. It helps us share more stories of innovation defeating bureaucracy. Subscribe if you haven't already, because we're diving into the engineering that mechanics weren't supposed to understand. Back to March 1944 and the modification that wasn't allowed to work. Robert James Shafer grew up in Wichita, Kansas, where his father worked as a master machinist at the Cessna Aircraft Company, one of the largest aircraft manufacturers in the American heartland during the 1930s. Young Robert learned early that aircraft were just machines, complicated assemblies of interconnected systems, but still fundamentally just machines that could be understood, modified, and improved through systematic thinking. His father brought home blueprints and technical drawings, teaching him to read engineering specifications and understand dimensional tolerances before he could read cursive writing. By age 12, Robert could calculate fuel consumption rates, understand range equations, and solve for unknowns in systems of equations that described aircraft performance. His education stopped at high school graduation in 1938. The Depression had devastated his family's finances. No money for college existed despite his strong grades in mathematics and physics. He went straight to work at Boeing's Wichita plant as an apprentice machinist, learning to fabricate aluminum parts to tolerances measured in thousandths of an inch. The job taught him lessons that engineering school never could. Engineering drawings represented ideal conditions, perfect materials, theoretical performance. Actual aircraft required constant modification, adjustment, and improvisation to work reliably under real operational conditions where temperatures varied, materials weren't perfect, and tolerances accumulated. He spent 4 years at Boeing, advancing from apprentice to journeyman machinist. He learned to operate every machine in the shop: lathes, mills, drill presses, grinders. He learned to read blueprints and work backward from desired performance to required modifications. His supervisors noticed his ability to diagnose problems through systematic analysis. When other machinists saw broken parts, Shafer saw failed systems that needed redesign. One incident in 1941 defined his approach to engineering problems. A Boeing Model 75 trainer aircraft experienced repeated fuel pump failures. Standard procedure was to replace the pumps with identical parts and hope the problem didn't recur. Shafer examined the failed pumps and noticed they all failed in the same way, bearing wear that indicated excessive vibration. He traced the vibration back through the system, discovering that the engine mount had been modified during production to save weight, and the weight saving had eliminated vibration dampening that protected the fuel pump. His solution was elegant. Machine a new engine mount that restored vibration dampening while maintaining weight savings through strategic material removal in non-critical areas. The modified mount weighed 1.4 pounds more than the production mount, but 3.7 pounds less than the original design. It solved the fuel pump failure problem completely. Boeing Engineering adopted his design across the entire Model 75 production line. Shafer was 20 years old. He enlisted in the Army Air Force in December 1942, 1 year after Pearl Harbor, requesting assignment as aircraft mechanic based on his Boeing experience. The Air Force sent him to technical school at Chanute Field, Illinois, for 16 weeks of intensive training on P-51 Mustang fighters, the newest and most advanced fighter in the American inventory. He graduated second in his class of 84 students. First place went to a student with engineering degree from MIT who excelled at written examinations. Shafer excelled at practical problem solving. When instructors presented mechanical failures, he diagnosed causes faster than anyone else by thinking through system interactions. When classroom instruction focused on following procedures from technical manuals, Shafer understood why the procedures worked and when they didn't apply. His approach to aircraft maintenance was systematic and comprehensive. Aircraft systems interconnected in complex ways. Fuel system affected engine performance by controlling mixture and flow rates. Engine performance affected electrical system by varying generator output. Electrical system affected everything from radios to landing gear to flight instruments. Understanding one system in isolation was inadequate. You had to understand how every system affected every other system. By January 1944, Shafer was serving as crew chief for the 4th Fighter Group at RAF Debden, England, maintaining P-51B Mustangs that escorted B-17 and B-24 bombers attacking targets in Germany. The mission profiles frustrated him. Bombers penetrated 450 miles into Germany to hit industrial targets. P-51 fighters could fly 450 miles on internal fuel, meaning they escorted bombers to the target, then had to turn back, leaving bombers unprotected for the final 100 miles and the entire return flight. German fighters, primarily Bf-109s and F-190s, understood this perfectly. They waited until P-51 escorts turned back, then attacked the bombers with overwhelming force. Bomber losses on unescorted portions of missions averaged 11.4% in January 1944. On missions where P-51s could provide escort for the entire route, losses dropped to 2.8%. The mathematics were simple. Extend P-51 range, reduce bomber losses. The P-51B Mustang in early 1944 represented the best American fighter in Europe, but its range-limited strategic impact. Technical specifications tell the story of a nearly perfect aircraft constrained by fuel capacity. Wingspan, 37 feet. Length, 32 feet 3 inches. Weight empty, 7,125 pounds. Maximum takeoff weight, 11,600 pounds including repilot, ammunition, and fuel. Engine, Packard VU-1650 or Starion 3. A license-built version of the British Rolls-Royce Merlin 61 producing 1,450 horsepower at 3,000 RPM. Fuel consumption at cruise power settings, 70 gallons per hour. Internal fuel capacity, 269 gallons in 6 tanks, 4 in the wings, and 2 in the fuselage. Maximum range on internal fuel, 950 miles total. But combat radius only 475 miles because aircraft had to return to base. The standard solution was drop. Tanks, external fuel tanks, that could be jettisoned when empty or when combat required maximum maneuverability. The P-51B was equipped to carry two 75-gallon drop tanks, one under each wing. Total external fuel, 150 gallons. Total fuel capacity with drop tanks, 419 gallons. Maximum range with drop tanks, 1,300 miles. Combat radius, 650 miles. But 650-mile combat radius still wasn't enough to escort bombers to Berlin, which sat 900 miles from English bases. The bombers needed escort for 1,800 miles round trip. The P-51 with standard drop tanks fell 200 miles short. The solution existed: larger drop tanks. The P-51 could theoretically carry 108-gallon drop tanks instead of 75-gallon tanks. The extra 66 gallons of fuel would extend range by exactly the 200 miles needed to reach Berlin. But there was a problem: the fuel transfer system. The P-51's fuel system used a mechanical pump driven by the engine to transfer fuel from drop tanks to internal tanks. The pump was designed for 75-gallon tanks, with specific fuel flow rates and pressure characteristics. The 108-gallon tanks, being larger and shaped differently, created different pressure characteristics that the standard pump couldn't handle reliably. Wright field engineers said the entire fuel pump system would need redesign. New pumps would need to be manufactured and tested, and the modification would take minimum 6 months to implement safely. 6 months meant summer 1944. 6 months meant thousands more bomber losses. 6 months meant the strategic bombing campaign might fail before fighters could protect it. Shafer looked at the problem differently. The fuel pump worked fine. The issue was the transfer valve that controlled fuel flow from drop tanks. The valve was calibrated for 75-gallon tanks. Modify the valve to handle different flow rates from 108-gallon tanks, and the problem was solved. No new pumps needed, no major redesign, just a better valve. He spent 3 weeks in January 1944 studying the fuel system, tracing every line, understanding every component. The transfer valve was a mechanical device weighing 1.8 pounds, containing springs, seals, and precision machine surfaces that opened and closed based on fuel pressure. Shafer measured fuel pressures from 108-gallon tanks borrowed from a P-47 Thunderbolt that used the larger tanks. The pressure characteristics were different, but not drastically different. The valve could handle it with modifications. On February 7, 1944, Shafer machined a modified transfer valve in the maintenance hangar machine shop after hours when supervisors weren't watching. He used scrap aluminum from damaged aircraft parts. The modification involved recutting internal passages to handle higher flow rates, replacing springs with slightly stiffer springs to handle different pressures, and adding a small bypass channel that would prevent vapor lock at high altitude. Total weight of the modified valve, 2.1 pounds, 0.3 pounds heavier than the original. He installed it on a P-51B that was scheduled for a training flight the next day. He didn't tell anyone. He didn't request permission. He just did it, reasoning that if it worked, he'd explain later. If it failed, he'd fix it before anyone noticed. February 8, 1944, test flight. Pilot was Captain Donald Gentile, an ace with 21 confirmed victories who trusted Shafer's mechanical skills completely. Mission was a routine training flight, but Shafer had asked Gentile to fly it as if carrying 108-gallon drop tanks. The test would determine if the modified valve could transfer fuel reliably at all altitudes and power settings. Gentile took off at 8:47 a.m. with two 108-gallon drop tanks installed. The tanks were full, total 216 gallons of external fuel plus 269 gallons internal. He climbed to 25,000 feet, approximately the altitude where bombers cruise during missions to Germany. At 25,000 feet, he switched from internal fuel to external tanks and monitored fuel flow. The modified valve worked perfectly. Fuel transferred smoothly from drop tanks to internal tanks. No vapor lock, no pressure problems, no flow interruptions. Gentile flew for 2 hours 14 minutes, consuming all external fuel and returning with internal tanks still full. The modification worked exactly as Shafer had calculated it would. When Gentile landed and reported the results to Shafer, the mechanic's response was characteristic. Fuel system doesn't care what size tank you hang on the aircraft as long as the valve can handle the flow rate. I made the valve handle the flow rate. Simple engineering. But it wasn't officially authorized engineering. Shafer's modification violated technical orders. He'd modified a critical aircraft system without approval. He'd machined parts without authorization. He'd installed them without documentation. If the aircraft had crashed due to fuel system failure, he would have faced court-martial for causing the crash. Gentile understood the implications. He also understood the strategic necessity. He told Shafer to make modified valves for every P-51 in the squadron. Shafer said he'd need help. Gentile said, get help. So Shafer recruited 8 other mechanics who knew how to operate machine shop equipment. They worked night shifts, machining modified valves from scrap aluminum, installing them on P-51s during routine maintenance when supervisors weren't watching. By February 28, 1944, 22 P-51s in the 4th Fighter Group had modified fuel transfer valves. The modifications were undocumented, no forms filed, no official approvals, just better valves that allowed larger drop tanks. The controversy erupted when the group commander, Colonel Donald Blakesley, discovered the modifications during an inspection on February 29th. Blakesley was checking aircraft in preparation for a maximum range mission scheduled for March 4th when he noticed 108-gallon drop tanks on aircraft that weren't supposed to carry them. He demanded explanation from the maintenance officer. The maintenance officer, Captain Thomas Holloway, explained about the modified transfer valves. Blakesley asked who authorized the modification. Holloway admitted nobody had authorized it. Technical Sergeant Shafer had just done it. Standard military procedure called for immediate disciplinary action. Unauthorized modifications violated regulations. Blakesley should have grounded the aircraft, removed the modifications, and court-martialed everyone involved. But Blakesley was a fighter pilot who understood that Berlin was 900 miles away, and standard P-51s could only fly 650 miles. He made a command decision that would either save his career or end it. I don't know anything about unauthorized modifications, he told Holloway. I see P-51s equipped with 108-gallon drop tanks. Apparently somebody figured out how to make them work. Test them on the March 4th Berlin mission. If they work, I still don't know anything about unauthorized modifications. If they fail, I'll know who to court-martial. March 4th, 1944, 6:30 a.m. Briefing for the first Berlin mission in a crowded operations room at RAF Debden, where 89 pilots sat on folding chairs facing a large map of Europe. Target was the Erkner ball-bearing plant in eastern Berlin, a facility producing 2,000 to 300 precision bearings daily for German aircraft and tank production. Distance from RAF Debden to target, 900 statute miles, 782 nautical miles by the navigation calculations that pilots would use. Round trip, 1,800 statute miles through the most heavily defended airspace in the world. No P-51 mission had ever attempted that distance. The published maximum range for P-51B with standard 75-gallon drop tanks was 3,300 statute miles total, meaning 650-mile combat radius. Berlin exceeded that by 250 miles. The 4th Fighter Group would fly escort using P-51s, equipped with Shafer's modified fuel systems and 108-gallon drop tanks. Nobody had told 8th Air Force headquarters about the modifications. As far as official records showed, this was a routine maximum range escort using standard equipment. Colonel Blakesley's briefing emphasized fuel management. You'll be carrying 485 gallons total. That's 269 internal plus 108 per wing external. Cruise at 265 indicated airspeed, 2,050 RPM, auto lean mixture. That gives you 70 gallons per hour consumption. Do the mathematics. You have 6 hours 55 minutes fuel. The mission will take 6 hours 30 minutes if everything goes perfectly. That's 25-minute reserve. Do not deviate from cruise settings except during combat. Do not chase German fighters away from the bomber stream. Conserve fuel like your life depends on it, because it does. Takeoff began at 9:02 a.m. under overcast skies with ceiling at 3,000 feet and visibility 6 miles in light rain. 22 P-51s rolled down the runway in pairs, each carrying external fuel load that made the aircraft handle sluggishly during takeoff. The 108-gallon drop tanks hung from pylons under each wing, creating 216 gallons of fuel weighing 1,296 pounds in addition to the aircraft's normal weight. Takeoff speed increased by 8 miles per hour due to the added weight and drag. The formation climbed through the overcast at 9:23 a.m., breaking into clear air at 8,000 feet. They continued climbing to 25,000 feet, the altitude where they would rendezvous with the bomber stream. Fuel consumption during climb was higher than cruise, approximately 120 gallons per hour, as engines worked hard to lift the heavy aircraft to operational altitude. By the time they reached 25,000 feet at 9:51 a.m., each P-51 had consumed 98 gallons, leaving 387 gallons remaining. At 10:17 a.m., they joined the bomber stream, 348 B-17 Flying Fortresses, flying in combat box formations that stretched 40 miles across the sky. The P-51s took up escort positions. 4 ship flights positioned 2,000 feet above the bombers and offset 5,000 feet to the sides, ready to intercept German fighters before they could attack the bombers. At 10:47 a.m., the formation crossed the German border near Venlo in the Netherlands. The P-51 switched from internal fuel to external drop tanks. Shafer's modified transfer valves activated. Fuel began flowing from drop tanks through the new valves into internal wing tanks. The pilots monitored fuel gauges closely, watching external tank gauges drop, while internal tank gauges held steady or increased slightly. Captain Don Gentile, flying as flight leader in one of the modified aircraft, watched his fuel gauges with professional interest. External tanks showed 108 gallons per side at 10:47. At 11:02, 15 minutes later, external tanks showed 90 gallons per side. Fuel was flowing at 18 gallons per side per 15 minutes, which equaled 72 gallons per hour total, slightly more than the predicted 70 gallons per hour, but within acceptable range. More importantly, the flow was steady. No fluctuations, no vapor lock symptoms, no pressure irregularities. Shafer's valve was working exactly as designed. By 12:17 p.m., all external fuel was consumed after 90 minutes of flight. Each aircraft had transferred 216 gallons from drop tanks to internal tanks. The pilots jettisoned empty drop tanks, watching them tumble away below the formation. The aircraft felt suddenly lighter, more responsive. Fighter performance improved immediately without the drag and weight of external tanks. The formation continued toward Berlin on internal fuel. German fighter activity increased as they penetrated deeper into Germany. Luftwaffe controllers were vectoring fighters to intercept, trying to mass sufficient numbers to overwhelm the American escorts. But the German fighters had a problem. The P-51s that usually turned back at the German border were still there at 12:30 p.m. when the formation was 200 miles inside Germany. The P-51s that should have been low on fuel were still providing escort. At 1:03 p.m., the formation reached Berlin. The sky over the city was filled with flak, black puffs of explosive shells detonating at 25,000 feet, creating a deadly gauntlet that bombers had to fly through to reach their targets. The P-51s couldn't help with flak. Their job was to prevent German fighters from attacking, while bombers were most vulnerable during their bombing runs. The bombers began their runs at 1:09 p.m., flying straight and level while bombardiers aimed through their Norden bomb sites. German fighters appeared, trying to attack during this vulnerable phase. Bf-109s and FW-190s dove from above, attempting to break through the P-51 escort screen. Gentile, with adequate fuel reserves thanks to Shafer's modification, didn't have to worry about fuel management during combat. Previous missions had required constant fuel calculation during combat, always worried about having enough fuel to return home. This mission, he had sufficient fuel to engage aggressively. He intercepted 3 Bf-109s that were diving toward a B-17 formation. The combat lasted 47 seconds. He destroyed 2 Bf-109s and damaged the third, his 23rd and 24th confirmed victories. Across the entire fighter group, the mathematics of fuel reserves changed combat effectiveness. Pilots with adequate fuel engaged German fighters aggressively. Pilots worried about fuel conservation fought defensively. The difference was measurable in combat results. the 4th Fighter Group destroyed 11 German fighters during the Berlin mission, while losing no P-51s to air combat. The psychological impact on German fighter pilots was significant when they realized American fighters could now escort bombers to Berlin and still had fuel for sustained combat. The bombers completed their runs by 1:34 p.m. The formation turned for home, beginning the 900-mile flight back to England. This was the portion of the mission that previously had been most dangerous for bombers, the long return flight without fighter escort. Now the P-51s stayed with them. The formation landed back at RAF Debden between 3:47 p.m. and 4:12 p.m. Total mission time, approximately 7 hours for most aircraft. Every P-51 returned safely. No aircraft lost to fuel exhaustion, no fuel system failures. Average fuel remaining when aircraft landed, 47 gallons, approximately 40 minutes flight time. The mission had worked with comfortable fuel reserves. That evening, Colonel Blakesley filed mission report describing the first successful fighter escort to Berlin. He mentioned that P-51s used 108-gallon drop tanks. He didn't mention modified fuel transfer valves. He didn't mention unauthorized modifications. As far as official records showed, P-51s had always been capable of carrying 108-gallon tanks, but word spread through unofficial channels. Mechanics talked to mechanics. Shafer had friends at other fighter bases. Within a week, mechanics at the 357th Fighter Group at RAF Leiston were machining their own modified transfer valves based on Shafer's design. Within 2 weeks, the 339th Fighter Group at RAF Foulmere was doing the same. Within 3 weeks, 210 P-51s across. 6 fighter groups had modified fuel systems, all installed without official authorization, all spreading through what pilots called the crew chief network. The official discovery came on March 27, 1944, when a Wright Field engineering team visited RAF Debden to inspect P-51s. They were investigating reports of extended range missions that exceeded published aircraft specifications. During inspection, they discovered the modified fuel transfer valves. The lead engineer, a civilian named Robert Patterson with 20 years' experience in aircraft fuel systems, was furious. He reported directly to 8th Air Force headquarters that field modifications had been made to critical aircraft systems without authorization. He stated that the modifications were unsafe, untested, and violated every procedure for aircraft modification approval. He recommended immediate grounding of all modified aircraft, removal of all unauthorized parts, and court-martial of mechanics who performed the work. The recommendation went to General James Doolittle, commander of 8th Air Force. Doolittle faced a decision that would affect the entire strategic bombing campaign. Follow proper procedure, ground 210 fighters, and lose fighter escort capability for weeks. Or ignore procedure and accept that mechanics had solved a problem that engineers said couldn't be solved without 6 months of work. Doolittle made a decision that prioritized mission over bureaucracy. He called Patterson to headquarters on April 2, 1944, for a meeting that included Colonel Blakesley and Technical Sergeant Shafer. Patterson presented his case for immediate removal of unauthorized modifications. Blakesley presented mission results: 23 escort missions to Berlin and beyond using modified aircraft. 0 fuel system failures. Bomber losses reduced from 8.4% on unescorted missions to 2.1% on missions with full fighter escort. Doolittle asked Patterson one question: can Wright Field design, test, and implement a better fuel transfer valve faster than mechanics are currently installing Sergeant Shafer's design? Patterson admitted that official procedures would require minimum 4 months to complete the modification program. Doolittle turned to Shafer and asked if his modification could be documented and standardized so other mechanics could install it reliably. Shafer said yes. He'd already written installation instructions for mechanics at other bases. The procedure took 4 hours per aircraft. The parts cost essentially nothing because they were machined from scrap aluminum. The reliability was proven by 1,147 combat flight hours without failures. Doolittle's decision became famous in 8th Air Force maintenance units. I'm ordering Wright Field to reverse engineer Sergeant Shafer's modification, document it officially, and certify it retroactively. In the meantime, The modification will continue being installed by field mechanics using Sergeant Shafer's instructions. Wright Field will provide official approval for what's already working. Patterson objected that the decision violated every engineering and safety protocol. Doolittle replied, "The Luftwaffe doesn't care about our protocols. They care that P-51s can now escort bombers to Berlin. I care about the same thing." The impact of the modification played out in statistics that told the strategic story. January 1944, before extended-range P-51s, average bomber loss rate on deep penetration missions was 8.4% per mission. February 1944, with partial extended-range coverage, loss rate dropped to 6.1%. March 1944, with full extended-range coverage, loss rate dropped to 3.7%. April and May 1944, loss rate stabilized at 2.1%. The reduction from 8.4% to 2.1% represented 75% decrease in bomber losses attributable to extended fighter escort coverage. In absolute numbers, the extended-range P-51s saved approximately 4,200 aircrew lives between March and August 1944 by preventing bomber losses that would have occurred without full escort coverage. German perspective on the P-51 range extension came from Luftwaffe documents captured after the war. A March 1944 tactical directive from Luftwaffe Fighter Command noted that American fighters were appearing over Berlin with sufficient fuel to engage in sustained combat. The directive stated, "Previous tactics of waiting for American escort fighters to reach fuel limits and turn back are no longer effective. American fighters now have sufficient range to escort bombers throughout entire mission. Luftwaffe fighters must engage despite American escort presence, accepting higher casualties." The psychological impact on German fighter pilots was significant. General Lieutenant Adolf Galland, commander of Luftwaffe fighter forces, wrote in his post-war memoir that the appearance of long-range P-51 escorts over Berlin in March 1944 marked the beginning of the end for German air defense. German fighters that had previously attacked bombers with impunity after American escorts turned back now faced American fighters throughout the entire mission. German fighter losses increased from 18% per mission in January 1944 to 34% per mission by May 1944, primarily due to engagement with long-range P-51 escorts. Statistical analysis conducted by the United States Strategic Bombing Survey in 1945 studied the impact of extended-range fighter escorts on the strategic bombing campaign. The analysis concluded that the ability to escort bombers to any target in Germany reduced bombing campaign duration by approximately 8 months and reduced total bomber losses by 6,400 aircraft. The extended range capability came almost entirely from field modifications to fuel transfer systems that allowed use of 108-gallon drop tanks. Technical Sergeant Robert Shafer remained at RAF Debden throughout the war, continuing to maintain P-51s and train other mechanics in fuel system modifications. He was promoted to Master Sergeant in May 1944 in recognition of his technical contributions. He never received official recognition for the fuel transfer valve modification because official records stated the modification was designed by Wright Field. The actual design work remained in the crew chief network, where mechanics knew who really solved the problem. After the war, Shafer returned to Wichita and resumed work at Boeing's plant, eventually becoming a production supervisor. He retired in 1982 after 44 years in aircraft manufacturing. He rarely discussed his wartime service. In a 1977 interview with the American Aviation Historical Society, he was asked about the P-51 fuel system modifications that enabled Berlin escort missions. His answer captured the essence of practical engineering versus theoretical engineering. Wright Field engineers said the modification couldn't be done safely without major redesign. But they were thinking about perfection. I was thinking about good enough. The valve didn't need to be perfect. It needed to transfer fuel reliably for 7 hours. I made it do that using parts machined from scrap. The mathematics of fuel flow don't care if your parts came from official procurement or from a maintenance hangar machine shop. Physics works the same either way. The P-51 Mustang's range, extended by unauthorized field modifications that spread through maintenance networks faster than official bureaucracy could approve them, changed the strategic balance of the air war over Germany in 1944. Modern military historians generally agree that the extended-range P-51 was the single most important factor in achieving air superiority over Germany in 1944, which in turn was essential for the success of D-Day and the subsequent liberation of Western Europe. The principle demonstrated by Shafer's modification, that field maintenance personnel working on actual aircraft understand system limitations and solutions better than distant engineers working from specifications, influenced post-war military aircraft maintenance doctrine. The modern Air Force encourages field-level modifications through formal channels that allow rapid testing and implementation of improvements identified by maintenance personnel. March 4, 1944, lasted 7 hours of flight time that proved a principle. One mechanic, one 2-pound part, one modification that wasn't allowed. When practical engineering defeated theoretical engineering, when field mechanics defeated headquarters bureaucracy, when scrap aluminum machined in a maintenance hangar changed strategic warfare, Technical Sergeant Robert James Shafer modified P-51 fuel transfer valves without authorization, enabled 210 aircraft to escort bombers to Berlin, reduced bomber losses by 75%, saved approximately 4,200 American aircrew lives, changed the air war over Germany. Design spread through unofficial networks to 6 fighter groups in 3 weeks, without a single official approval, not because he followed procedures, because he solved problems. If this story moved you, please like and subscribe. Your support preserves these histories of mechanics who changed wars from maintenance hangars. Tell us in the comments, where are you watching from? We honor the crew chiefs who ignored regulations to save lives. Thank you for keeping their stories alive.